Hello everyone. For my topic, I will be covering wearable devices. I will be giving you an insight onto wearable devices, what they are, how they function, and I will be giving a history about them. I will also be analyzing one particular wearable device in detail. Uh, so let us proceed further. I would like to give a very brief overview of what we will be covering. First is introduction to wearable devices. We will be following up with a very short history on what we have been using so far. We will be covering how these wearable devices work. Then we will proceed to one particular example in detail, smart shirts. And then I will be concluding with a small snippet about the future of these devices. So we begin with the introduction. Once we start, the first thing which comes into mind is what are wearable devices? In general, wearable devices are any devices that can be worn, but for the purpose of our class, we will restrict it to this definition, which basically means that they are any computing and intelligent devices that can be embedded into things that we wear on a daily basis. Notice the word computing and intelligent. Basically, they are electronic devices which have a processing ability. With this definition, we will move forward. I think we have all come across wearable devices in our day-to-day life. Perhaps you've read about them or you own a few, but they have become a new trend as such. This picture is probably going to depict quite a few of them. The skeleton over here is wearing quite a few wearable devices. First one is the Google Glass, which is invented for your augmented reality. They basically superimpose the real world in the virtual world. It is a big hit with gaming consoles. Other than this, you have your smartwatches. These watches help you monitor your runs, your health status, etc. Some examples are probably the Pebble smartwatches as mentioned, and the new Apple iWatch. The Apple iWatch will release in September. Going forward, we also have wristbands and bracelets, which are again for health and fitness monitoring. They're very popular. They're getting popular in the fashion industry, and they are used for military purposes. Now we have jewelry and ornaments. Jewelry generally has ring sensors, Bluetooth embedded into it. It has a huge range of medical applications, which is just yet being explored. Apart from this, we have shoes currently, which are used for fitness and military purposes again. Apart from the following mentioned here, we have a whole new set of sensors coming in, and those are the smart fabrics. They are either the smart shirts or the drum pants, both of which were released commercially in 2013 and 14 respectively. We will look at that in the consequence slides. Now I will be giving you a short history about these devices. So these devices are plenty in nature. You have everything from wristwatches to shoes to shirts and numerous applications to glasses. All of these in this picture barely comprise of less than one-fourth of the total number of wearable devices currently available. So let's see how these devices have progressed through history. The initial wearable device, the armors, were invented around 3 millennia ago. Since then, you can see that the total number of wearable devices from 3 millennia ago to 2014 has risen exponentially. In fact, there has been an exponential increase from 1990s to 2014. So the rate at which technology is progressing is indeed amazing. Okay, I would like to cover a very short history now. We did not have electronic wearable devices till 1950s, and even those were not commercially viable till 1980s. So I will cover from the 1980s to 2014 a few devices of importance or popular culture. In the early 1980s, we had the Seiko smartwatch and the Casio data bank. The Seiko smartwatch was a PDA device, which was for your day-to-day activities and monitoring as such. Your Casio data bank was a scientific calculator which could handle 16 alphanumeric characters. Then in the late 1980s, it moved on to the gaming industry where it went to Star Trek Communicator and the Nintendo Battle Power Glove. Neither of these was very famous, but they were very entertaining nonetheless. From the 1990s to the 2000s, the wearable devices improved quite a bit. The Forget Me Not was again a PDA device which did not require to be programmed by a keyboard, unlike the Seiko smartwatch. Then we had the Forget Me Not then we had the emergency watch, which could transmit emergency pulses far and wide as and when required by the user. Then we had the portable computing PCI Tech from IBM. Followed by this, we had the first cyborg device trying to be emulated in this period. Then we moved on to the 2000 to 2010 era, where we had the Project Cyborg 2, which was successful, which was a neuron hand emulator, which had a neuron impulses uh, which were picked up on and used to move different objects. Followed by this, we had the JetLev, which was a flying device, which wasn't very viable. Then the Fitbit tracker, which is very popular, used to track your fitness measurements. And finally, the HAL suit, which was used for on paralysis patients uh, and to help them move. Then we move on to 2012 to 2013, where we had Whistle, which was for dogs, wearable devices on dogs to track them. Then the NFC ring, which is used to for easy communication between any two people, easier share of contacts. All you do is shake your hand. Then you have the drum pants, which was again a smart fabric based on piezoelectric crystals, which would create different sounds based on where you tap it. Then you had the Google Glass, which is of course very well known, which is used for augmented reality. Next, we move on to 2014 and we'll see what comes. We have the we have wearable devices from the company Cuff, which is again emergency devices designed like jewelry. It's fashion technology. Then we have the Apple iWatch, which is due to release in September 2014, which is like the Pebble smartphone. And then, of course, Intel released its latest smart shirt recently, which we now come to how it works. Like any other device, we have to have a sensor, we need to have transducers, we need to have a processing unit, and we need to have display devices or output devices of some sort for any device function. So to go forward, this these wearable devices, considering they are wearable, have two kinds of sensors. Either they are touch sensors, that is, they pick up signals from your body by touch alone, or non-touch sensors. So usually touch sensors are all biosensors. So this is how they look. You have a biological element, which is usually your wrist or your uh, probably your near your heart center near your chest area. So this biological element is what is transmitting your pulse. Then you have your sensor part, which uh, contains all your uh, sociocultural part, which is nothing but your enzymes which are reacting. Based on this enzymes and how they react, you have certain signals produced, and these signals are sent to a transducer of sorts. This transducer then further goes ahead to convert them to electrical signals that are readable by a processor, and this can go further either to display an audio device as signified by the red line, and it will also go to your signal processing unit, which is a microcontroller or a microprocessor, which is usually calibrated. This microcontroller or processor basically takes in your electrical impulses coming from your biological sensor and processes them further with a predefined set of voltages or numbers which have been calibrated into it with multiple trials. Based upon the outputs received, it will communicate back to the display or audio device to inform you, maybe through LCDs, through headphones, through speakers, alarms, even your OLED displays. This, of course, the microprocessor control unit is powered by a battery supply, which is renewable. The bigger the battery life, it is more commercially viable. Apart from this, your microprocessor and controller unit will also communicate to these communication devices, whether it be through Wi-Fi or NFC, Bluetooth, or your mobile networks. For certain biological sensors, for certain applications, say military or medical, just displaying is not enough. We need a feedback loop, something which will go back to your biological sensor, to your biological element, and create the necessary action required so that we can change how the signal appears next time. So this is also particularly required in the for gaming applications because we need to, for the game to proceed, we do need a change in our input. Apart from the biological sensors, we have other sensors which can be used, which are non-touch sensors like microphones and cameras, which pick up on speech and uh, light. So both of these are processed by your signal processing unit, your microcontroller. Usually these microcontrollers or processors don't usually require a lot of power, uh, but they do need to have high processing speeds for them to work effectively. So they are generally small devices with very high speeds. One example is your Intel Edison core processor, which I will be covering in the next slide. Next, so one example which I will be covering now is the smart shirts. Smart shirts are again made out of smart fabric. Smart fabric is nothing but yarn or any other kind of fabric which is interwoven with communicative channels like optical fibers for constant data communication throughout the shirt. It is also woven with sensors. So Intel came out with its smart shirt in May 2014, and it is specifically made for fitness as such, for people who like to exercise. So these are some features of it. It is used to track your heart rate, the conductive fibers, through a pulsometer there. The information from these pulsometers is taken from your conductive fibers to a microcontroller, and this information which is processed is sent over a smartphone to a smartphone over Bluetooth or Wi-Fi or even 3G depending. This can be transmitted to hospitals as and when required. This particular smart shirt uses the Edison microcomputer. It is the new microcomputer from Intel. It was released a year ago. It is a 400 megahertz dual core processor and with a one core microcontroller. This particular smart shirt can be used to monitor people who have to be monitored 24/7, like old and aging people who need to have constant care. So this is how your Intel smart shirt looks like. Apart from this, the microcomputer in this shirt is put in a separate box which can be worn as a belt. The rest of the fabric is washable. While washing, you will have to take out the fabric. This was the latest model. The initial model of the smart shirt was made in Georgia Tech in 2005, and it was made mostly for military purposes. Since I don't have the in detail depth about how the smart shirt made by Intel works, I will be exploring how the Georgia Tech one was woven. The technology as such has not changed that much. This is how the West created by Georgia Techniques, Initial West. So now we come to the working with smart chip. Before we actually cover the working, why do we need the smart chip? The smart chip is a very effective way of tracking the health of your wounded soldier or your um, medical patients who are lying at their deathbeds. It is a continuous monitoring device and all the patient needs to do is wear it. So this is how the smart shirt architecture looks. The red lines here are the optical fiber. I will go through each part in detail. The first one is your microphone, the sensor over there. The red lines, as I mentioned, is the optical fiber which is woven into the smart shirt seamlessly. It's a plastic optical fiber and it is woven in such a way that there are no holes or discrepancies near the arm joints. Next is the basic grid system, a way which is connected to the data bus and is a way of locating where the soldier is wounded. Next is the data bus itself, which is a way of communicating from the sensors to your processing unit, which is the brown square thing at the bottom. When you have sensors, you have multiple sensors all across the smart shirt, whether it be a pulse rate monitor or a temperature sensor or a respiratory sensor or so on. Finally, you have your multifunction processor down there, which does most of your processing and also does the uh, function of transmitting your signals to your base camp when the soldier is wounded. The way it works is that when the soldier is wearing the shirt, uh, if a bullet penetrates if a bullet penetrates him, the optical fiber which is woven into this shirt will break at some point. The microprocessor down there will keep transmitting pulses through the optical fiber continuously from one end to the other. Once it reaches the receiver end, the optical fiber reflects it back and the microprocessor picks up on the reflected signal. In case there is a break in the optical fiber network somewhere, the signal will not be reflected back and the microprocessor will know that the soldier is wounded. It will then send a signal out through the data bus, which will use the grid to pinpoint the exact location of the wound. Based upon the location of the wound received, uh, the microprocessor will then send a signal to the base camp. In the base camp, the people monitoring the system will look at the location and see if it is a critical location. Say if the soldier is wounded near the heart or the lungs, then he might require immediate assistance. So this is a very important concept because we can't waste it helps us not waste time on not so critical injuries. Apart from this, the sensors on this particular smart shirt, which is 3840 with smart shirt, are movable based upon the size of the rider. So this pretty much covers how the smart shirt works. So now we come to the future of wearable devices. The future of wearable devices, as mentioned here, is greatly interlinked with nanotechnology and wearable computing. Nanotechnology will serve to improve upon your wearable devices in future. Going forward, we will require a lot less intrusive devices. We will require smaller devices which have more functions, which we can't view, which are not required to be worn on a daily basis over and over again. Uh, as in time, maybe with help of all our organic semiconductors, we will reach a time where we don't need devices to be wearable, but they will be embedded in us. So they will be devices which we won't even notice exist within us. So with this topic, I would like to conclude that wearable devices have a very bright future indeed. Thank you.